World. Welcome back to C Language Programming. In the Anatomy of C program, the upper part of our program are the preprocessor directives, particularly the define directive that define a global constant. In this example, z is equal to 50. And then another example of global declarations are the variables, global variables, as well as this another example which is a global constant declared is declaration is const int y is equal to 49. Okay, then followed by function prototype. Okay, then finally the main function. Okay, then below the main functions are the sub functions. Okay, in this case it's hello and the world. Now an alternative declaration would be putting the sub-functions on the global declarations. It's also possible. And you don't have to declare the function prototypes. Okay, so let's proceed. So our topic for today is about control loop or control loops. But we'll be focusing on just one control loop, which is the for loop. What is a loop? A loop or looping means repetition. No? The for loop looping is one of the control structures in any programming languages. We display hello world in the monitor. So how are we going to do it? Using the printf function. So we're gonna do it three times. Okay? Here. Printf hello world, printf. Just keep repeating it. No? So that is repetition. But how about if you're going to do hello world 1,000 times? So are you gonna keep copy and paste the printf hello world 1,000 times, just like this one? So it will be some no or tedious to copy and paste printf hello world for 1,000 times. So applying the structure control structure for loop. So time you know the for loop structure is only written once as well as this printf. But if you're going to execute this one, it will be uh, printed 1,000 times. Okay, so if you're going to run this in code blocks, so this will be the result. No? So you'll be scrolling from the top to bottom and generating hello world 1,000 times. Now, how about if you're going to uh, hello world vertically? No, you're going to add a new line. Let us say 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's it. So that's how simple uh, looping is or loop. But let's dissect the for loop structure. So you have this word for followed by an open close parenthesis. Okay, inside the open close parenthesis are the upper limit. In this case, I assign the x as integer data type. So this is the lower limit of our count of our loop. Then of course followed by uh, semicolon. No? Then followed by the upper limit. In this case, x is less than 1,000. Then of course followed by a semicolon. Then followed by the increment counting or the counter. Now are going to how do you do the increment counting rather? Okay, so starts from zero because x equals to zero. Then it will stop when it is 1000. So, so which means counting from 0 to 999, so there are 1000. Hello world. Okay, so the increment counting x plus is also mean a postfix increment. Or you could say x is equals to x plus 1. On the other hand, if you're going to start the lower limit from 1 and then end up to 1000, then that's also possible. It will print hello world 1000 times, starting from 1 and then ends in 1000 because of the less than or equal operator. Okay, when it reaches when the increment counting it reaches 1001, so it won't no longer print hello world. Okay, so if you're interested in mathematically x equals to x plus 1 does not sound uh, uh, mathematically possible. So actually this is the how the x equals to x plus 1 implemented in computers. Okay, so it is x new is equals to x old plus 1. Now, if since x is equals to 1, so that will be the old value. So the new value 1 would be x new is equals to 1 plus 1, so 2, and so on and so forth, 3, and so on and so forth. Okay, now going back to our flowchart topic. Okay, so this is how the for loop structure is being implemented in flowchart. No, of course, an oval block with a start, then followed by an arrow, then a rectangle, which means processing. No, it's going to process the assignment of x, which is equal to 1. For some flowcharts, they would require additional process for global declarations of variables or declarations of variables. Then followed by parallelogram, for our output, print hello world. Then followed by the another process which is the incrementing, of the count x. So x is equals to x plus 1. Then followed by a decision block. No, this will determine if it will end the for loop or it will continue on printing hello world. Now let us say let's start with x equals to 1. Okay, so it will print hello world. Then x now will become 2. Then you will be asked by a decision block, is x less than or equal to 1000? So actually x is equals to 2 and it's still less than 1000 or equal to 1000. So it will go back again and again until it reaches, let us say, 998. So it will print hello world and it will add here x is equals to x, so it becomes 999. So take note, it has already printed hello world 998 times. Okay, then 999, that's the value of x, and still less than or equal to 1000. So it will loop back. Okay, so it will be printing the 999 hello world. So there are still 999. Then x now adding plus 1 becomes 1000. So is x less than or equal to 1000? Yes, so it will continue. So the value of x now is 1000. So for the 1000th time, it will print hello world. But then again, with the incrementing counter, x equals to x plus 1 becomes 1001. So the question, if x is less than or equal to 1000? No. So it will end. So that's how this for loop is implemented uh, in a flowchart. Okay. How about the lower limit or the initial value is equal to 0? Then the task is to print hello world 1000 times, implemented in a flow chart. Okay, so take note, this is less than 1000. So the same in the decision block is or if, no, is x less than 1000. Okay, so the same scenario, this will print hello world from 0 to 999. So therefore there are 1000 print hello world, no, starting from 0 to 999. But after it reaches 1000, so it's no longer less than 1000, so it will end. Okay, so about increment counting of numbers, no, instead of hello world. This time we're gonna display numbers incrementing accordingly. Now, particularly from 0 to 9, so how are we going to do it? Okay, so it's the same thing. X is initially started from 0 until less than 10, so that is 9. Okay, then of course x plus plus, but this time the percent I, no, string format would be followed because I is for integer, and this is the values of x will be uh, printed. Okay, so using block, you've noticed that the display or the output is horizontally displayed from 0 to 9. Okay, so how about the numbers from 1 to 10? No? Displaying numbers from 1 to 10. Increment counting of numbers. So, of course, you start with x is equals to 1 and end when x is equal to 10. Okay? So, that's the difference between 0 to 9 and 1 to 10. So, the same thing. So, in code blocks, you'll be expecting this result from 1 to 10. Okay. So, there are softwares that could implement flowcharts, no? This is the Flowgorithm, no? So let's try Flowgorithm, particularly for the, okay, so the oval is the main function or the main start. Okay, so you right click here, and in this case, we are required to initialize the value of x or declare x, okay, as an integer, then follow the for loop. Okay, so in the for loop, double click the variable x, then it started from 1, then it will end say 10. Okay, then in this loop, we're going to display an output. Okay, particularly, uh, is it numbers or is it hello world? Anyway, let's say hello world, hello world. Okay, then if you're going to execute this one, you notice that there is actually 10 hello worlds being displayed. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you like, the display would be uh, the variable x. Okay, you can simply change the output to x. Okay, so the output is the x itself. So let's start to play. Okay, so this. Okay, so 1 to 10. So that's the output. Okay, so if you're interested in applying your skills in flowchart, you could try the Flowgorithm software. It's an open source. Okay, so let's continue. Oh, how about the decrement? No, decrement counting. So which means the display starts from 10, then stops at 1. Okay, so the lower limit now is assigned to 10, is equal to 10. And the upper limit is now 1. But take note of the sign. Instead that it is less than, this time is greater than or equal to 1. Then the the decrement counting, so which is the x minus minus, or the postfix decrement. Okay, so we're going to apply this in blocks. This will be the result. So print x, no. Of course, you need to add space so that the output will be properly spaced. So 10, 9 until it reaches to 1. So much with the basic of for loop. So let's try to apply the for loop in art, no, in animation. Let's try. It's just a basic animation, no, for us to appreciate uh, how for loop was being used in game development. Okay, so allow me to show you go ahead, uh, a video or a JF file. So that's how it is, uh, the result of doing the snake game. Okay, now let's try to open the file. If I still have the file, now I'm gonna use the code blocks. Okay, still opening the code blocks. Okay, so if I'm not mistaken, where's the snake? Yeah, let's try to open the snake. Okay, so actually I've just downloaded this sample in the net. No, if you're going to notice, there are loops. Okay, so there are loops found in the code. The code is long. It's long. Okay, okay, so there are four loops. Okay, there are four loops. But anyway, let's try to play. Okay. Okay, so welcome to the mini snake game. Press any key to continue. Okay. Press any play to continue. Okay, we'll be using the up, down, left, right cursor. Okay. So here we go. Okay. Up. Oh, down. Very good. Oh no. Ah. Anyway. Okay, so how a simple uh, snake game was being uh, programmed, no, using part of it are the for loop. So in this venture, we're gonna use Turbo C, no, and side by side with the code blocks, no. You can download it in this website. Now for the users, you can download the Turbo C Droid because in the CPP Droid it doesn't support Goto XY, no. So you cannot play along with the XY coordinate system. However, in code block, so this will be the additional codes you'll be need. No, you'll be adding the Windows.h besides the standard I/O, and you'll be just copying this code, no, function for the Goto XY because it doesn't have a built-in Goto XY function. So you have to copy this one, as well as for the delay, no, and this uh, for loop, or in this delay function, just to delay, no. we're actually idling the system, not idle. System idle. It doesn't do anything. In the for loop, if you have complex instructions, you can use the open and close brace. No, if it is just a single statement, you can use it without. But in this case, it's required. No, so by default, you could always use the start brace and the close brace for the closing, in closing the for loop uh, structure. Okay, so we're gonna do this, the blinking text. So is it possible for the text to be blinking? Okay, so actually, if we're going to analyze the program, there is a for loop here. Okay, so blinking it 10 times, and that with the application, the clear screen, no? Clear the screen. So we're going to go back in code block. You'll be needing the system function, then open double quote, close double quote with the CLS command. Okay, for the yeah for the clear screen. That is equivalent to CLR SCR in Turbo C++. And do not forget the get key for the get characters. It will uh, pause the output or holds the screen for this to the display. And do not forget the return, no, return value of the main function, which is end, or else it will display error. Okay, so it open the C++. Okay, so you click this one. So this is just being emulated in kuan in the Windows because it's no longer supported, but emulation is still possible. Okay, just like other games, you can play Battle City, in an emulator. Okay, so that makes it possible by through emulation. Okay, so you can use the mouse, but for a while after you have run program, you won't able to use the mouse. So take note of the red uh, colors, the file F for the edit is letter E, search S. So the F, E, and then the S and so on and so forth means that you can use an alternative function, Alt keys. So in my case, I'm gonna press Alt, the Alt function, then press F. Okay, so then I'm gonna click new. Okay, so let us say what was it? Include. By the way, we'll be using the double quote, no? Because in Moodle, the angle brackets are not supported. But anyway, it's the same thing. Standard.h. Then the next is rather, if I'm not mistaken, Conyo, no? Control input output for the clear screen. And gonna include the DOS, no? Disk operating system.h for the delay. Okay. So main, okay, so the open brace. Okay, so let's start using X as our variable X, then start the for loop. Say X from say 1 to, was it 10 times? No? Then followed by the increment, which is X plus plus. Oh no, do not put a semicolon. Then do not forget the open brace. No, since it's more than one statement or complex statement. or compound statements. So the first thing is we need to screen, okay, and followed by the semicolon. So this one is for clearing the screen or the monitor. By the way, when I use the double backslash, it means that this is no part of not part of the code, no? It will not be compiled. It's just a comment or a remark. Okay? Then when you screen, you add a delay. What was the delay? Let's try 50 milliseconds. So the unit is, we can change that, no? Delay in 50 milliseconds. We can change that in 100. Time we're going to print, no? Let's say hello world. Okay. Then another delay, no? Because if you're not going to include hello world between the screen and the printing of the hello world, then you could barely notice that it blinks, no? Okay, so do not forget to use the good character, no? Okay. By the way, that is not required, no? It's just for the sake that we could see the result. Then last is the return. Okay. Okay. So let's try to compile. Alt C. There are no errors. So there are no errors. Then we go to run. Alt R and run. Okay. So have you seen the hello world blinks 10 times? So let's make it slower. Let's say 100. No? 100. As well as this one, 100. Okay. And let's say 20 times. Take note, the delay now is changed to 100 milliseconds. So let's try to run. Okay. So the hello world now is blinking. Okay, that's it. So go back to the blinking text. No. Now let us say, by the way, these are the important keys to remember. Do not forget the preprocessor directives or the libraries. Then the clear screen, the delay in between the printf. Okay. Next is how about if you're going to do it in code blocks. So if you're going to do it in code blocks, so you'll be needing the standard IO as well as the Windows H. Okay, so as well as you need to add the delay function. No, we're just using the for loop, and the unit for this delay is not a function of time, not a function of seconds or milliseconds. It depends on how fast your computer is able to do it. Okay, so it's been a while, so we're gonna just open the code block. We're not going to encode because the video is taking us very long. Uh, I think I have the blink. No, blink. It's the blink text. Oh, okay. I have here the blink text. I'm gonna minimize just the go to XY because it's not yet part of this main function. Okay, so do not forget the hello, the Windows H, and to add the the delay function. No, so then so it's similar to Turbo C++. No, the code here below. No, instead of using a clear screen, this time it's using uh, system CLS. Okay, so it's similar to CLR, SCR, or clear screen in turbo C. Okay, so the same thing. I'm just using 500. So let's try to run this one. Oh, there you go. So hello world now is blinking. Okay. So next is okay. I forgot this one. That there is a GIF that's keep on running to display the output. So we go now to blink the center. So is it possible to blink the text hello world at the center? So you need to add the function this time, get the built-in function, the go to XY, which is built in Turbo C. Okay, so let's try to open our, where is our Turbo C? Okay, so if you happen to minimize the Turbo C to go back to the zoom screen is you need to press and hold the Alt key and enter. Okay, so the idea here is to locate at the center. So what was the coordinate? Go to XY. So it's a built-in function. The X is around 13. I know it's around 30, I guess, or 35. Then the Y would be around 12 or 13. Anyway, let's try this one. So this is the XY coordinate. No? So X is for the 35 and 12 is for the Y. So Alt R, run. Oh, there you go. So hello world now is blinking at the center. Now, if you want to save your work, you just simply click Alt, then just simply save. No? I want to name this. Uh, this is Blink C. No, Sing or Singer. That's C. Okay. So go back to our uh, display PowerPoint presentation. Where is it? Okay. So in the key blocks, no, you need to add the go to XY function declaration because it's not available, no, unlike in Turbo C. That's why I'm presenting this in Turbo C as well because during our evaluation or examination it would be too long for me to keep using declaring this built-in function, no? Just like as you will be using it here, and so we're going to assume that the in exam it's Turbo C++ or anyway whichever is discussed in this section. Okay, so these are the important uh, codes: the delay, the go to XY, and the go to XY. Okay, so let's try to open the code blocks. Okay, so this time since I already added the go to XY function. By the way, you can search this function code in the net. Okay, just simply copy and paste. Okay, it's not part of our discussion. No, that's why I presented Turbo C. No, so that we won't be bothering with this one. Okay, so do not forget that the system CLS is clear screen. So I'm gonna add the go to XY here. Go to XY. Then if I recall that was the X is 35, then 12 for the Z. Let's run. Oh, there you go. The hello world now is at the center. Okay. Okay, so let's continue. The same thing is GIF. It will automatically looping back the result of the program, the output of the program. So the question is, which has short? Is it this one Now using the Turbo C plus plus, or is it this one using the code blocks? In code blocks, we are not emulating. No, we are running the application truly. 64 in a 64-bit machine. That's why the software can download the 64-bit version or the 32-bit version. But in the Turbo C++, it's emulated. Okay? So answering the question which has the shorter code, okay, so it's the Turbo C. So in our examination, uh, it is assumed that if ever we're going to use GoToXY or clear screen, okay, or system CLS, okay, it's already integrated. No? It's assumed that it is already integrated. Okay? Oh, we go now to the running. So how are we going to do the running text? So instead of a blinking text, this time we're gonna let the text run. So this time we're gonna change the values of x as it increments, no? Or what is meant by changing x values? No? It's not constant. If it is constant, then it's just blinking. If it is varying, then it will be running. Okay, then uh, let's try this one. Oh, okay, that's the running text using the code blocks. Let's try that apply in. Okay, so do not forget to open this DOS box, the emulator, and you click Alt Enter. Okay, so this time the go to XY now must be variable. So was it 1 less than 65? So therefore, this 35 will be changed to X. And Y is constant at the center. So let's try to run this one. Alt R. Oh, there you go. It's running. I guess it's not running. It's walking. Okay. So perhaps we could decrease the value of delay. Okay. So we're gonna change it back to the 50. Let's try 50. Okay. Alt. Okay. So it's a little bit faster than this time. Let's try. Let's try 10. Okay. Let's try 10. So this time it's 10. Okay. So let's try to move. No, let's try what will happen. So we just simply make the get function as a comment. So, okay, so that's what happened. No? It doesn't hold the screen or stop the screen. Simply uh, exit the screens automatically. Anyway, we have seen the hello drawing. Okay. Okay, so we go back now to our PowerPoint presentation. Oh, how about the running forward, back and forth? Yeah, actually, it's simple, no? Just use the concept of the decrement, no? Decrement. And this first loop, it's increment. The second loop is decrement. That's it. You just simply replicate this one, and the values of x is decreasing, whereas this one is it's increasing. Okay. Yeah, let us see. Oh, it's not displaying. Okay. There. Okay. Forward, backward. Okay. Again. Display. Forward, backward. Okay. So time and do the square move as well or rectangular move. This time we're going to notice that in the main function, no, we just simply call the functions that you have created. Let's say you go forward, downward, leftward, upward. So this is the seemingly the result. The asterisk will be moving forward and downward. Okay. and so on and so forth. So this is why we need to know how to use basic function declaration. No? So that in our main function, there are only few no codes that we see. No? And the rest of the codes are on the top or below. No? It's up to you. So your assignment is to make an program in C code with a Christmas theme using for loops. Okay, you can draw a Christmas tree that is blinking for a moment. Of course, you need to implement it in several functions so that in the main function you just call a blink Christmas tree, such as the name, no? Blink Christmas tree. Then for a while, the next function call will be somebody's running, and just like in this video, you know. Okay, so I hope I inspire you to make programs. No, this I'm just teaching you the basic. No, hopefully, if you're going to advance further, no, particularly in web development, no, or other embedded system programming, no, you'll be using this art, no, in programming as well. Okay, bye bye.